No, no one's gotten. But just in case later you have, an extra 20, 25 minutes and you're looking for something to do, Miss Checker could always use some views. Go subscribe. All right. Alright, so all the answers in items 1 through 4 are called terms. A term is a number, variable, or the product of a number and or variable. Write an expression to represent the sum of your answers from item 1, 2, and 4. So each of the terms, so in item 1 we had 16, right? It was 4 by 4. And then in 2 we had 4x. And then in 4 we had 20. So if it says sum, what operation are we doing? We're adding. So what ones can we add together? Alright, so like terms, so 16 and 20. So that's 36. So can I add 4x to that and say 40x? Alright, but we're dealing with an expression because we don't know what it equals. So the expression is just, there's no equal sign if we're looking at an expression. So we'll just leave it like that. We can't go any further because these are numbers. And this is, a number and variable. So this 4x, is it representing the number 4 or what does that represent? Alright, so 4x equals, means that we have 4 x's. It doesn't mean that we have the number 4, it just means we have 4 of whatever's after it. So like if I had 4 smiley face, what does that mean? It means we have 4 smiley faces. Alright. So looking at, it says expressions like the answer number 5 are called polynomials. A polynomial is a single term or the sum of 2 or more terms with whole number of powers. So list the terms of the polynomial we wrote in item 5. So what would we had 36, and what was our other term? 4x. So those are our 2 terms. So what are the coefficients? So coefficient is the number factor of a term, is the numeric factor of the term. So here we have 4. So the coefficient there is 4. And then the constant term is like the plain old number. There's no variable attached to it. So what's the constant term of our polynomial? 36. So the coefficient is 4. Our constant term is 36. All right, so questions there? And with the so the polynomial, so the terms are whole number powers, so that's going to be important. So, if we have a fraction, so I'm looking at D here, we have x to the 1/2. That's not going to be polynomial. And how could we write like 1/2? Is there another way that we could write that power? Okay, 0.5. Alright. Everything else we have whole numbers. And so here we have a negative. How could we, that would be like 1 over x squared, right? Alright, so, and that kind of gets to something different because that's 1 over x squared. That's actually something else that's called a rational expression. And then here, we could write that as the square root of x, and that's a square root function, and so that gets into some different things. All right, so let's look at the degree of a term. It's the sum of the exponents of the variables contained in the term. So we want to identify the degree and coefficient of each term of the polynomial. So looking at our first term, we have 4x to the fifth. That has a degree. Our degree is the power. So what's the degree of our first term? 5. And what's our coefficient? 4. So then our next term is 12x cubed. What's the degree of that term? 3. And then our coefficient is 12. So our next term is x squared. What's the degree? And what's our coefficient? 1. So number in front. So remember, if there's nothing in front, that means we have how many of them? 1. All right, so what is the degree on this minus x? 1. And what's our coefficient? What's the number in front? Negative 1. And then here's a tricky one. What's our degree of our constant term? 0. So this, we're looking at the number above it. That's the power. So remember, a polynomial is the sum of different terms. And so with this, I'm adding a negative 1x. Counting things. If you were in, a warehouse, you can have, this x cubed or x to the fifth, could represent something, and then you have different. A lot of real world applications are going to look like this, where you have multiple variables, where you have different things that you're dealing with, and they're all affecting the outcome of something. And so you have to count up and combine everything and differentiate. So we're kind of at the beginning skill levels of the application, but in industry, in finance, you'll see equations like this. In manufacturing, where you have different components that are all working towards a final outcome. Managers of stores will use this because they have to figure out how much supply demand and how much they can, And here's an example. Right now, my daughter wants one of those fidget spinners. So we have been on the hunt for them. So they're very popular. So we went to Lewis, and Lewis didn't have any. And so, when the manager of Lewis is ordering, stock for the week or month, however they do it, they have to anticipate, they want to get some of these fidget spinners because they're hot, right? They know that parents are going to bring the kids in to buy them. And, when the parents are there, they may stop and get other things. So what are, in addition to the fidget spinner, which might be the X in the equation, what are the other things that they should have on hand that parents are going to want? And then you have to look at, how many fidget spinners do they have room for in addition to the other things? Because Lewis also has, people coming in for the pharmacy. And so if you're coming into the pharmacy to get a prescription, what are other things that you need? So they have to take all of these different components and figure out what's the best amount, because you don't want too many fidget spinners, because in a few weeks they won't be cool anymore, right? You won't have the high demand because people will have them. So you don't want to have extras on hand, but you want to have enough. You don't want to run out because now you're losing business. So they have to kind of balance, are you going to have, a lot of kids and families, because those needs are different from people who are sick or, older going to the pharmacy. So kind of balancing out what you have room for in the back to maximize profits. That's kind of a use for this. All right. So for this polynomial, we have 2x cubed y minus 6x squared y squared plus 9xy minus 13y to the fifth plus 5x plus 15. List each term and identify its degree and coefficient. Identify the constant term. All right, so let's start with the constant term. Your constant term, let's refresh the vocabulary, is it's the only number, the only just plain old number, right? So what's the constant term here? 15. So our constant term equals 15. So it says list each term and identify its degree and coefficient. Alright, so we have 2x cubed y. So what's its degree? Let's look at the x. What's the degree? 3. And what's its coefficient? 2, the number in front, right? Alright, and what's the power on the y? 1. Alright, so here, what's our coefficient? Positive or negative? Negative. So signs matter. So this is, we have a negative 6 in front. And then what's the degree on the x? 2. And then the degree on the y? 2. Alright, so our next term. So our coefficient is positive 9. And what's our power on the x? 1. Power on the y? 1. Our next term, what's our coefficient? Negative 13. Now, do we have a power on the x? 0. And then what's the power on our y? 5. All right, the next term, what's our power on the x? 5. Oh, 0. What's the power on the x? 1. And what's our leading coefficient? I threw you off. I threw you off because I asked coefficient first for the last one. All right, so and then what's the power on the y? 0. All right. All right. So degree of a polynomial is the greatest degree of any term in the polynomial. All right. So here we have a polynomial. What's the degree? What's our highest? We have x squared, right? So it's a degree of 2. And what's our constant term? 7. All right, so our constant term is negative 3. So it's the number on the end. And then 3. Yep. And then our degree is 3. And the 2. Okay. And so this one, our highest degree is 2. All right, so then we have this nice little diagram, right? This is like one that you want to almost cut out and like paste on the bathroom mirror so you see it every day. All right, so our leading coefficient is our coefficient in front of our leading term, which is our term with the highest degree. So that's like the leading coefficient, it's the person out front, right? Yes. So our highest degree is 5. And so our leading coefficient is the number, is our coefficient on that term, which happens to be 7. This polynomial has 3 terms. That's called a trinomial. Tri for 3, like triangle, tricycle. And then our constant is our number hanging out on the end. And then we often put things in descending order, means we start with the highest and then work back. Yeah, because you want the leader out front. All right, and then we have our table for how we name things. A one-term polynomial is called a monomial. A two-term polynomial is called a binomial, like bicycle, bifocals. And then trinomials, 3 terms, and then polynomial is anything more than 3 terms because mathematicians get lazy. And so we don't have a quad polynomial or quintinomial or hectonomial or anything like that. Octanomial, just stop. So all polynomials after that.
Science, you do.
Science.
Yeah.
Alright, so questions on that? Alright, so number 2, so that's binomial. What's our leading coefficient? 3. So when we put them in descending order, who's up front? 3. What's our constant term? This one's tricky, think about it. Our constant term, that's our final number. So then what's
0? The athletic trainer is here. Thank you.
So this is plus 0, so our constant term. Alright, so the next one. How many terms do we have? 3. So I'm trying to fit it all in. So our leading coefficient is just the number. So -2. What's our constant term? 6. And then our degree, it's squared, so 2. Wait, for this one?
No.
This one?
Yeah. There's the 2 after the x. And then there's technically x.
For the degree, it's just the highest one. So you're just looking at whatever is the top. Why? So but the degree, the highest degree, it's kind of like if you take everybody in your class and line them up and rank, but then everybody just gets the highest person's GPA.
Oh, that'd be awesome.
So that's kind of like the degree.
Oh.
So you put them in. You put your leading coefficient is whoever is ranked number 1, and then everybody just gets that person's GPA. Everybody has that degree.
Okay.
Are they the same? But no. You just each of these just has 1. Just the highest, the degree is just whatever the highest one is. All right, so for the next one, how many terms do we have? 1. So what would you call that one? Monomial.
50, 0.
And the leading coefficient is 15, the number in front. Our constant term is 0 because we're adding 0 to the end. And then what's our degree? 2. All right, so this next one, how many terms? 4. And what do we call that? Polynomial. What's our leading coefficient? And then our constant term. And our degree is 3. We are looking at that up there. All right, so how do you guys feel about this?
Great.
All right.
For the next one.
Oh. So what's the leading coefficient? What's the number in front of a square? Just 1. All right. Are we okay with the rest? Do we need to finish that?